Hey guys, in this video series, we're running through some really easy to use microtonal scales in 31 tet. I think most people, when they hear we're going from 12 notes per octave to 31 notes per octave, they just get overwhelmed and they don't know where to start. So hopefully this video series will help with that. The first scale that we're going to explore is submixolydian, and the concept is very simple. So what we're going to do is we're going to take the mixolydian scale and change all of the minor intervals to sub-minor intervals. So just to refresh everyone's memory, the mixolydian scale is made up of the root, the major second, major third, perfect fourth, perfect fifth, major sixth, minor seventh, and then the octave. And in 31 tet, this equates to the Ito steps 0, 5, 10, 13, 18, 23, 26, 31. And this is what Mixolydian sounds like in 31 tet. So Mixolydian only has one minor interval, the minor seventh, and we're going to change that to a sub minor seventh. So in 31 tet, that means we're going to change it from Ito step 26 and we'll change that to 25. And this is what the new scale submixolydian would sound like. And if we look at the step pattern, we can see that it's quite uneven. So between the first and second scale degrees, we have a major second. From 2 to 3, we have another major second. From 3 to 4, we have a minor second. From 4 to 5, we have a major second. From 5 to 6, we have another major second. And then from 6 to 7, we have a sub minor second. And then from 7th to the octave, we have a super major second. So we have 4 different step sizes in the scale, so it is quite an uneven scale. If we look at the different intervals, so I've just listed the intervals for Mixolydian on the top. So we can see we have 6 perfect fifth relationships, which I've highlighted in green. And there is one greater tritone, which represents the 10/7 ratio. If we look at submixolydian, you can see that the perfect fifth between the 7th and 4th scale degrees has been lost, um, and that's become a major fifth. You'll also note that the interval between the 3rd and 7th scale degrees has changed from a greater tritone to a lesser tritone, and the lesser tritone has a ratio of 7/5. In 12 tet, we only have one tritone, but in 31 tet, there's 2 different ones. So to summarize, in submixolydian, you have 5 out of 7 scale degrees, which have a perfect fifth above them, compared to mixolydian, which has 6 scale degrees with a perfect fifth above them. So this is important because perfect fifth relationships make it a lot easier to build consonant chords, and from there build nice chord progressions. So next we'll map out what triads we have in submixolydian. So on the first scale degree, we have a major third and a perfect fifth. So the first chord is a major chord. On the second scale degree, we have a minor third above it and then a perfect fifth. So we have a minor chord. On the third scale degree, we have a minor third and then we have the lesser tritone above it. So I'm going to call this a lesser diminished chord. On the fourth, we have another major chord. On the fifth, we have a sub minor third above it and then a perfect fifth. So I'm going to call this a sub minor chord. On the sixth, we have another minor chord. And then on the seventh, it gets a bit complicated. So we have a super major third and then a major fifth above the seventh. So I'm going to call this a semi-augmented chord. And that's because in an augmented chord, the fifth is raised to a minor six. So here, the fifth has been raised to a major fifth, which is one Ito step sharper than a perfect fifth, but it's flatter than a minor six by two Ito steps in 31 tet. So I'm going to call this semi-augmented, and this is what it sounds like. So in summary, those are the triads of submixolydian. There are five perfect triads. So there's two major chords, two minor chords, one sub-minor chord, and then we have one lesser diminished chord, and then one semi-augmented chord. We also have four sus4 chords available and four sus2 chords available. So because we have two major chords, two minor chords, and plenty of sus chords with this scale, we can easily build chord progressions that are pretty much what we're used to hearing in standard 12 tet, and then maybe we can throw in one microtonal chord to add flavor and make it sound new. And that's why I think this scale is a really easy place to start if you want to try and make microtonal music in 31 tet. There's only one microtonal note in the scale, and there's plenty of chords that we're familiar with from 12 tet. And this is what the chords sound like up and down the scale. And this is what they sound like through the circle of fifths. Next, we'll get to examples of different chord progressions. So I've just color coded the different chords up the top. So the first chord progression we're going to look at goes 1, 6, 4, 5. So we have the major chord on the first, minor chord on the sixth, major on fourth, and sub minor on fifth. With all these chord progressions, I'm going to play them 4 times, 2 with simple voicing and 2 with more expansive voicing. So this is what this one sounds like. The next example we're going to look at is 1, 4, 2, 5. So we have major on the first, major on fourth, minor on second, and then ending with sub minor on fifth. With all these chord progressions, I am using a different oscillator for each one, so you guys can hear a variety of different sounds. I've just noted here which one I've used here on the middle left. I am relying on a website to do this for me, so hopefully that website has the right tuning. The next example I'm going to go to is 4162. So we have major on the fourth, um, major on the first, um, minor on the sixth, and minor on the second. So this is actually not a microtonal chord progression. So this is using chords that we're all familiar with from 12 tet. So the next example we'll go through is 6251. So this is going backwards through the circle of fifths. And then we'll go through the next example, which is going forward through the circle of fifths. So 1, 5, 2, 6. then the next example we have is 1756. So we start with major on the first, semi-augmented on the seventh, subminor on the fifth, and then minor on the sixth. And then the last example we'll do for triad progressions is 6, 4, 3, 5. So we have minor on the sixth, major on the fourth, lesser diminished on the third, and subminor on the fifth. Cool. So next we'll look at what seventh chords we have available in submixolydian. So on the root, we have a major chord plus a subminor seventh, which gives us a harmonic seventh chord. This chord is microtonal. It can't be played on a standard 12-tet instrument, and that's because the subminor seventh represents a 7:4 pitch ratio, and that doesn't exist in 12-tet. The four notes of this chord together approximate the fourth, fifth, sixth, seventh harmonics, so it's supposed to sound very stable, despite the fact there's a tritone between the third and the seventh. And this is what it sounds like. On the second scale degree, we have a minor third, perfect fifth, and minor seventh. So we have a minor seventh chord. And on the third scale degree, we have a minor third, the lesser tritone, and then a minor seventh. So I'm going to call this a lesser diminished minor seventh chord. Despite there being a tritone in this chord, there's also a perfect fifth between the third and seventh, so I think the chord still sounds usable. On the fourth, we have a major seventh chord. On the fifth, it's a bit unusual because we have a sub minor third, a perfect fifth, and then a minor seventh. So I'm going to call this a subdominant seventh chord. A dominant seventh chord has a major third and a minor seventh. So if we take the major third in a dominant seventh chord and change it to a sub minor third and keep the minor seventh, I'd say that that chord should probably be called a subdominant seventh chord. Obviously, this isn't gospel, so if you have a better idea of what it should be called, just leave that in the comments. Um, this chord is going to be slightly dissonant as there is a major fifth between the third and seventh. And this is what it sounds like. On the sixth, we have another minor seventh chord. So on the seventh, it's a bit complicated. So we have a super major third, a major fifth, and a super major seventh. So I'm going to call this a semi-augmented super major seventh chord. I know these names are kind of long, but in 31 tet, we have a lot more notes. So we have a lot more types of chords. And because of that, we need a lot more words to describe what we're talking about. And this is what the seventh sounds like. So to summarize, in submixolydian, we have three seventh chords which have two perfect fifths in them. So we have two minor seventh chords and one major seventh chord. Then we have two chords which both have a perfect fifth and a lesser tritone in them, and that would be the harmonic seventh chord on the first scale degree and the lesser diminished minor seventh chord on the third scale degree. And then we have two chords which have a perfect fifth and a major fifth in them, and that would be the subdominant seventh chord on the fifth scale degree and the semi-augmented supermajor seventh on the seventh scale degree. And this is what the chords sound like up and down the scale. and this is what they sound like through the circle of fifths. And next, we'll go through some examples of chord progressions. So the first one here is 1, 6, 4, 5. So you can see we've got the harmonic seventh chord on the first, the minor seventh chord on the sixth, major seventh on the fourth, and the subdominant seventh on the fifth. The next example we'll go through is 1, 4, 2, 5. So we have the harmonic seventh chord on the first, major seventh on the fourth, minor seventh on the second, and just the sub minor triad on the fifth, not the seventh chord. The next example we'll go through is 4, 1, 6, 2. So major seventh on the fourth, harmonic seventh on the first, minor seventh on the sixth, minor seventh on the second. Example 4, we have 4, 2, 1, 6. So here we have some extensions to ninth chords. So first we have the major ninth chord on the fourth, sus4 ninth on the second, harmonic ninth on the first, and minor seventh on the sixth. The next example we'll go through is 6, 2, 5, 1. So minor seventh on the sixth, minor seventh on the second, subdominant seventh on the fifth, harmonic seventh on the first. Next example we'll go through is 1, 7, 5, 6. So harmonic seventh on the first, semi-augmented supermajor seventh on the seventh, subdominant seventh on the fifth, minor seventh on the sixth. Next example, we have 2, 7, 5, 6. So just changing the first chord versus the previous example. So we have minor seventh on the second, semi-augmented supermajor seventh on the seventh. For the fifth, we have the sub minor triad at 9. And for the sixth, we have the minor seventh. Next example, we have something similar, so 1753, so harmonic seventh on the first, semi-augmented supermajor seventh on the seventh. For the fifth, we have the subminor triad add 9, and then for the third, we have the lesser diminished minor seventh chord. And for the last example, we have 6435, so minor seventh on the sixth, major seventh on the fourth, lesser diminished minor seventh on the third, subdominant seventh on the fifth. So that's just a couple examples of different chord progressions you can build with submixolydian. This is obviously just a small sample of what is possible, so hope you guys can experiment and let me know if you find more interesting combinations. We will move on to the different modes. So just to clarify, submixolydian is a scale. It's a different scale from mixolydian because it has different step patterns. So it's a scale of its own. It's not a mode of mixolydian. Later on in this video series, when we get to subdorian, subaeolian, etc., those will all be different scales. They all have different step patterns from each other. So submixolydian is its own scale, and because of that, it has 7 different modes. Um, I'm not sure exactly what to call all of these 7 modes, so I'm just going to call them submixolydian 1, submixolydian 2, submixolydian 3, etc., 4, 5, 6, 7. And these are the different intervals for each of those modes. I'll just play the scale for each of these. So submixolydian 1 sounds like this. Submixolydian 2, submixolydian 3, submixolydian 4, submixolydian 5, submixolydian 6, submixolydian 7. So that's what each of the 7 different modes sound like. Um, we can also look at which modes are the brightest. So in order to calculate the brightest, I've just added up all the different Ito steps within the scale and summed that on the column on the right. So you can see each of the modes, what their total brightness is. So the sharper each of the intervals are, the more bright the scale is. Now that we've calculated that, we can also sort the modes from brightest to darkest, which you can see here. So the brightest mode is the 7th mode, followed by the 4th, the 1st, the 5th, the 2nd, the 6th, and the 3rd. So what you'll notice as well is that that order follows the circle of fifths, and that's the same for the diatonic modes as well. With the diatonic modes, the brightest mode is the 4th, which is Lydian, followed by Ionian the 1st, then Mixolydian the 5th, 2nd, 6th, 3rd, and the 7th. So with both of these scales, the submixolydian scale as well as the diatonic scale, as we move through the circle of fifths, we'll move from the brightest scale down to the darkest scale. One thing to note with the diatonic scale is that as you move through the modes from brightest to darkest, there's only one note changing at a time. So, for example, as you move from Lydian to, let me just get a laser pointer. So, as you move from Lydian to Ionian, the only note that changes is that the fourth changes from a lesser tritone to a perfect fourth. Then, as you move from Ionian to Mixolydian, the major seventh becomes a minor seventh. Then, as you move from Mixolydian to Dorian, the major third moves to a minor third. Whereas when you look at the submixolydian scale, you can see there's a whole lot of notes changing as you move through the different modes from brightest to darkest. What I've highlighted on screen is where the notes have changed versus the mode above it. So for example, with submixolydian 7, as we move into submixolydian 4, you can see that every note except the root has flattened. So I've highlighted all the notes that are flattening in orange and all the notes that are sharpening in blue. So from submixolydian 7 moving into the fourth mode, every note except the root has flattened. Then when we move from submixolydian 4 over to submixolydian 1, you can see that the fourth has sharpened from a minor fourth to a perfect fourth, whereas the seventh note has flattened from a major seventh to a sub minor seventh. So because there's a lot going on with submixolydian as you move through the modes, it's kind of hard to interpret what's going on. What we'll do is as we move to the next slide, I've mapped out exactly which note is changing and by how many Ito steps compared to the mode above it. So with the Mixolydian or the diatonic scale, you can see that only one note is changing with each move to the next mode. So from Lydian to Ionian, only the fourth has flattened, and it's flattened by 2. Then as we move from Ionian to Mixolydian, the seventh has flattened by 2, etc., etc. And if you list down what note is changing each time, you can see that the order of change follows the circle of fifths. So we've gone from the fourth flattening with the first move to the seventh, to the third, to the sixth, to the second, to the fifth. And you can see that this follows the circle of fifths in the opposite order to the order of brightness. So the order of brightness goes 4, 1, 5, 2, 6, 3, 7 and the order of notes changing goes in the opposite direction 4, 7, 3, 6, 2, 5. So with submixolydian, we have two changes moving between each mode. We have one note which is sharpening by 1 Ito step, and then we have another note which is flattening by 3 Ito steps. And if we map out what note is changing each time, you can see that that as well also follows the circle of fifths in the opposite order compared to the brightness of the mode. So if we look at what note is sharpening, we go from 1, 4, 7, 3, 6, 2. If we look at what note is flattening, it goes 4, 7, 3, 6, 2, 5. So these two changes are following the same order, but offset by 1. So you can see that the sharpening is actually occurring one step after the flattening by 3 that occurs here. You can see that these two changes here follow the opposite direction through the circle of fifths compared to the brightness of the modes. So you can see here the brightness of the modes goes 7, 4, 1, 5, 2, 6, 3, and this is going in the opposite direction. Anyways, that's it for this one. So full disclaimer, which you can see in the title, I am not a musician. My music theory knowledge comes from watching other people's YouTube videos and thinking about stuff on my own. So everything I say on this channel is stuff that I've thought about and just dreamt up. As more people start to use 31 Ito, the nomenclature will probably settle into something with more consistency that everyone agrees on. So please let me know your thoughts in the comment section below. Does anything I said make sense? Do you guys have better ideas for naming conventions? Let me know if there's any mistakes in this video. I'm sure there probably are. I used a website to create all the sound files for this video, and I haven't done ear training, so I have no idea if the intervals I mentioned actually match the sounds played. But if you're watching this, I assume you guys will, so please let me know. With that being said, thanks everyone for watching this video. Please let me know your thoughts in the comment section below. Let me know if this video was helpful or if there's anything you disagree with. Please like and subscribe if you'd like to see more content like this. I'll be releasing videos shortly on some more really easy to use scales that you guys can use. The next video will be on Subdorian.